Hi guys, welcome to lesson 4.4. In lesson 4.3, if you have not watched that video yet, it is critical that you watch 4.3 before you attempt to do this lesson, because this will make absolutely no sense to you if you haven't done the 4.3 video already. So just a little bit of a disclaimer for you. Again, if you're trying to do things out of sequence, 4.3 is obviously a prerequisite to understanding 4.4. Now, you'll notice that what we did in lesson 4.3, where we were factoring things that essentially looked like this. It was just x squared plus bx plus c. So we needed to find two numbers that multiplied to c, that added to b, and we were in good shape. Well, by adding this leading coefficient, something other than 1, this potentially throws a very, very big monkey wrench into our problem. This makes this whole process of factoring much, much, much more difficult. Now, the method that we talk about in the textbook, the method they talk about in the textbook for factoring this is very, very exhausting, and it's very, very frustrating. The book's method says list all the possibilities that we could use to make this, list all the possibilities that we could use to make this trinomial, figure out all the numbers we can get to multiply to 7, all the numbers we would add to get to 9, but oh, by the way, don't forget there's a 2 in there. So with that leading coefficient, that makes our process much, much, much more difficult. So what I want to do then is I want to talk about another method that we use, and the method that I'm going to refer to is called the snip method. Now, you might ask, why do we call it the snip method? Now, anybody that's had Mr. Snip, he's a teacher here at the high school, will recognize that name, and again, if you haven't, then you probably won't recognize that name. The snip method comes from a long time ago. He showed me this method, and I think it's probably the best way to factor something with a leading coefficient other than 1. I am going to post on the Moodle, as well as onto YouTube, an additional video that you can watch Mr. Snip show you his method. But essentially, this whole method is worthless because this doesn't really help us to get at the solution, especially the more factors there are of 7 and 2, the more difficult this is and the more time-consuming the process is. So instead, what Mr. Snip does is, we talked about this last lesson. We said, look, we need to find two numbers that multiply to make this last number. Well, if the leading coefficient here was 1, then we needed a number that multiplied to make 7. Well, there was no product there. So we needed a number that multiplied to make 7, that added to make 9. Well, because of this leading coefficient now, and we go ahead and we take a look here, now the leading coefficient's a 2. And so what we do in the snip method then is we say, look, I need to find two numbers that multiply to make whatever a times c is. So we're going to multiply to make a times c, and we're going to add to make whatever b is. So this product has to be 2 times 7. So we need two numbers that are going to multiply to make 14 that add to make 9. Well, let's think of the factors of 14. They are 1 and 14 and 2 and 7. All right, now going back to what we talked about yesterday, this last number is a positive. So the only way I'm going to get a positive is if the two signs match. So that means I either need double positives or double negatives. Well, as you can imagine then, we're going to then take a look at this middle term and say, all right, well, since this is positive 9, that means that I know I've got double pluses. All right, now, the only way I'm going to make 2x squared is if I have like a 2x and a 1x here. Because when I do the first, 2x times 1x is going to give me my 2x squared. But rather than think about it that way, in the snip method then we say, look, we're just going to figure out two numbers that multiply to make whatever 2 times 7 is, whatever a times c is, and then they have to add to make 9. Well, again, they have to both be the same sign, they both have to be positive. 1 times 14 is 14, but they add to 15, so that's not it. 2 and 7 add to 9, and so that's my pair right there. That's my pair that I need. All right, so before you circle that then, what I want to do then is say, all right, my two numbers are going to be 2 and 7. Somehow my two factors are going to relate to 2 and 7. Now this has something to do with what we call the rational zero theorem. Don't worry about what that is right now. We're just going to take these, and as a placeholder, I'm going to put an x on the bottom. I want to put them both over whatever a is. In this case, my a is 2. All right? Now, I put the x there just to kind of remind myself that the x goes with whatever number comes out from the bottom. Now, simplify this. 2 goes into 2 once, 2 goes into 2 once, and so this ends up being x and a 1, and so my first term is x plus 1. My second term, since 2 does not go into 7, I'm just going to leave this as 2x plus 7. Now, you're looking at that and going, wait a minute, really? That actually works? Well, absolutely. Let's go ahead and check our answer by foiling. x times x is 2x squared. X times 7 is 7x. 1 times 2 is 2x. And 1 times 7 is 7. What is 2x plus 7x? Well, that is 9x. And so you end up with 2x squared plus 9x plus 7. And that's where we started, folks. All right, so the SNP method works all the time. And we have to get lots of practice at this. You're not going to get good at this just by doing one example. So let's go ahead and let's try another example. Let's take a look at example number 2 here. Example number 2 says, well, we're going to take a look at this if the c is less than 0. Again, this whole thing is irrelevant because in the book, that what they're trying to do is they're trying to get you to separate it into when it's this, do this, when it's this, do this. SNP method works all the time, every time. Okay, we need two numbers that multiply to make whatever a times c is. In this case, a is 3, c is negative 2, and so a times c becomes negative 6. I need two numbers that multiply to make negative 6 that add to make negative 1, because again, they have to add to make whatever b is. So let's start thinking about factors of negative 6. Well, guys, the only way I'm going to make negative 6 is if I have a positive 1 and a negative 6, for example, or a negative 1 and positive 6, for example. So again, the ways that we can make a 6, let's first think about ways we can get a product to make a 6, and then we'll figure out the signs. 1 and 6, and 2 and 3, and those are the only ways I can multiply to make a 6. Now, going back to our discussion from yesterday, since this last term is a negative, what does that tell me about my signs in my two parentheses? Well, it tells me that I've got to have one of each because when I do the lasts, whatever these two terms are, I have to have a positive times a negative to get negative 2x. So I know I've got one of each. The question is, which one gets what? Some of you guys have already figured this out. It's got to be positive 2 and negative 3 because positive 2 plus negative 3 becomes negative 1. So that's my period. So I have 2 and negative 3 are my two possibilities. Now, as I said before, you take both of those and you write them over whatever a is with your x so that you don't lose track of your x. Okay, we don't want to put the x with the wrong part. I don't know if that makes sense or not. It should make sense as we kind of go through a few more of these. Now, 3x and 2, they don't simplify, right? 3 and 2 don't have any common factors. So my first term is staring you right in the face, 3x plus 2. The second term, because 3 and 3 are both obviously divisible by 3, we're going to cancel the 3 out, and again, we have to make this a 1, and we have to make this a 1. Now you can write 1x minus 1, or simply put x minus 1. Now once again, a good way to check is to go back and FOIL your product. 3x plus 2, x minus 1. 3x times x is 3x squared. So far, so good. 3x times negative 1 is negative 3x. 2 times x is plus 2x. And 2 times negative 1 is negative 2. What is negative 3x plus 2x? Well, that's negative 1x. And so you get 3x squared, take away x, minus 2, and that's exactly what we started with. So that's the SNP method. All right? So why don't you guys try a few? And again, I'll set it up here on the sides for you. You need to find two numbers that multiply to make a times c that add to make b. All right, you guys can fill in the a times c. Two numbers that multiply to make whatever the product of a and c is that add to make b. So take a few seconds, try those two problems, and then we'll be right back with a solution for you. All right, so in number 1, we need a product of negative 20 and 3. So the product of negative 20 and 3 is negative 60, right? So I need two numbers that multiply to negative 60 that add to 7. Now, there's a lot of factors of 60, guys. 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, and 6 and 10. That's the whole list. Now, again, if we're doing it the books method, not only do we have to consider those, but we also have to consider signs. So, again, this method does save you a little bit of time. Now, the only way we're going to get negative 20 here in our last term is if I have a sign that is one of each. Is that true? Well, again, if you have a positive times a negative, you're going to get negative. If you have double negatives, guess what? You get a positive. If you have double positives, you get a positive. So it's not going to work unless you have one of each. Well, that's helpful because now we need to get two numbers that add to positive 7 and that have different signs. Well, like, for example, positive 60 and negative 1. Well, that ain't going to do it. That's 59. Positive 30 and negative 2 is going to give you 28. And notice that I'm putting the negative on the smaller number because I know I need to get positive 7, so I want the positive on the bigger number, and the negative on the smaller number. So as I kind of go through this list, you can see pretty easily that this is going to have to be negative 5 and positive 12. Negative 5 and positive 12 makes 7, so that's my pair right there. So negative 5 and 12, kind of write those and separate them a little bit. Put them both over the leading coefficient, a, times x. Now, why do we do that part? Because now we get 3x minus 5. That doesn't simplify, so 3x minus 5. And it doesn't matter what order you put them in. I just put a positive and a negative, so I wanted to make sure that I put the negative with the negative. From there, 3 goes into 12 4 times. I end up with just 1x and 4, and so this is just x plus 4. And like I said, you can always go back and check, but that is the right solution. In number 2, I need two numbers that multiply to make 30, that add to make negative 13. Now, you should be noticing here, the only way we're going to get positive 30 here is that both signs match. Well, if they're both positives, you're never going to get negative 13, true? So that tells you that you've got double negatives here. The only way you're going to do this is by getting double negatives. All right? Two numbers that multiply to 30 that add to negative 13. Well, you can do 1 and 30 and 2 and 15 and 3 and 10 and 5 and 6. I think those are all the pairs that you can use to multiply to make 30. And as we said before, I need a pair of those that multiply to 30, which are all of these, that add to negative 13 when they're both negative. Because again, we got to have double negatives to get positive 6 and a negative 13. All right, so now we're going to go ahead and we're going to say, all right, this has got to be negative 3 and negative 10. So there's my pairing right there because they add to negative 13. Negative 3, negative 10, put them both over the leading coefficient with an x. Now, 5x minus 3 does not simplify, and so this one is simply 5x minus 3. The second one, because 5 goes into 5 once and goes into 10 2 times, this becomes simply x minus 2, and so our second term is x minus 2. Now, once again, you can always go back and check, but those are the correct solutions. All right, let's take a look at factoring with special patterns. We talked about special patterns in our previous lesson. We talked about this difference of squares pattern, perfect square trinomials, and so we've been over these already. These patterns are in the previous lesson. So if the leading coefficient is something other than 1, we don't just have to go to the snip method, although you could use that snip method and it would work just fine for you. Okay? The issue that you're going to find then is that because some of these are special patterns, this is the difference of two things that are perfect squares. So this is 4x and this is 6. Because 4x squared gives me 16 and 6 squared gives me 36. And so the difference of squares pattern simply says this is 4x plus 6 and 4x minus 6. Again, difference of squares is a sum and a difference. Okay? All right, in the next example for letter B, I recognize that 9y squared is a perfect square. What did I square to get 9y squared? Well, I squared 3y. In the last part, I squared to get 49. I had to square 7. So is that middle term the product of twice a, which is 3y, times b, which is 7? Well, let's check that. What is 2 times 3y? Well, that's 6y. And then times 7 is 42y. Cool, they match. So that means that this is a perfect square trinomial, and so this becomes simply 3y plus 7 quantity squared. Now, the long way is 3y plus 7 times 3y plus 7, and again, if you were to FOIL that out, you'd get back to where you started from. But again, we just want to write that as the product of 3y plus 7 times itself twice. We're going to use the square. All right, what did you square to get 25t squared? Well, you squared 5t, and to square to get 121, if you didn't know that, that's 11. So my question is then, is that middle term, since it's minus here, this is minus 2 times 5t times 11. Well, 2 times 5 is negative 10t, and then times 11 is negative 110t. And so when I do this and this times negative 2, I get that middle term, and so I know this is a perfect square trinomial. And so it's 5t minus 11 squared. You will get very good at recognizing those patterns later. If you don't see the pattern, then you can always use the snip method. But if you're doing the snip method for letter C, let's think about that. We got to find two numbers that multiply to make whatever 25 times 121 is. You might be here for a while. So look for these numbers here to be perfect squares. And then check to see maybe it might be a perfect square pattern. If not, you can always go snip method. All right, so try the 2 checkpoint problems. I'm going to guess because this is 3 terms and it's on a special patterns, this is probably a perfect square trinomial, and because this is the difference of two things that are perfect squares, it's probably difference of squares. But give them a shot and see what you come up with. All right, in number 3, I recognize that this is a perfect square. What did I square to get 16y squared? I squared 4y. What did I square to get 25? Well, I squared 5. Now, is twice the product of these two that middle term? Well, 4y times 5 is 20y, and if I double that, I get 40y. Now, because this is a minus, that tells me it's the difference of in a perfect square. So this is 4y minus 5 quantity squared. And again, if you expand that in FOIL, you will find that that is the correct factoring. What about this one? Because of the minus and that this is just two terms, that tells me this might be that difference of squares pattern. What did I square to get 2t squared? I'm sorry, 2x squared? I'll say it right. What did I square to get 4x squared? I must have squared 2x. And what did I square to get 81? Well, I must have squared 9. So this is simply 2x plus 9 times 2x minus 9. And again, the justification for why that's the sum and difference is in the previous lesson. Back in, actually it's in the special patterns from lesson 4.2. All right, so what happens if you can factor out a monomial first? Remember, a monomial is just some term, and so sometimes we can factor a term out first. Notice that in this example here, both are divisible by 4. So if I factor a 4 out, essentially what I'm doing is I'm bringing a 4 out of both of these terms. So factor 4 out of x squared, 4x squared, it leaves x squared. Factor 4 out of negative 4, that leaves negative 1. Now, you might think you were done here, but let's take a look at this. Is this a perfect square? Well, sure it is. What did I square to get x squared? I squared x. And what did I square to get negative 1? Well, what did I square to get 1? I must have squared 1. So actually, this is the difference of squares pattern as well. So it goes a little bit further. Now that's a little bit harder to find that one, but again, don't forget to factor completely. Okay, make sure you use any special patterns necessary. What about letter B? Well, in letter B, we can factor a negative 3 out of both of these. In fact, we can factor a negative 3y out of both of these. So if I bring a negative 3y out of here, bring a negative 3 out of negative 3y squared, basically that just leaves me a y. And if I bring a 3y out of negative 18y, that leaves me with a positive 6. Now again, how do we check that? If I were to redistribute, negative 3y times y is negative 3y squared. Negative 3y times positive 6 gives me my negative 18. Now, since y plus 6 doesn't factor anymore, that's a prime polynomial, we're done. We're going to stop there, and that's my solution. All right? Let's see if we can get some of that stuff out of there so you can at least see the answer. All right, in letter C, I don't like that this leading coefficient's negative. If that leading coefficient's ever negative, the snip method becomes much more challenging. All right, and so what I might suggest to you guys is anytime that leading coefficient's negative, I might just try to factor out something that's negative. Now in this case, since 4 does not go into 10, we can only factor out a negative 2. So if I bring a negative 2 out of negative 4m squared, that leaves me with 2m squared. If I bring a negative 2 out of negative 10m, that leaves me positive 5m. And if I bring negative 2 out of positive 24, that leaves negative 12. Okay? So now I need to find two numbers that multiply to make whatever a times c is. In our case, we have a times c to be 2 times negative 12, which is negative 24. And they have to add to make b, which is positive 5. Now, how am I going to get a negative product? Well, that means my signs are one of each, right? A plus and a minus. The question is, does the 2m go with the plus or does the 2m go with the minus? Well, let's go ahead and answer that question. Ways to make 24. 1 and 24, 2 and 12, 3 and 8, 4 and 6, and I think that's about it. Which of those pairs, when I have one of each, is going to add to make 5? Seeing it? Right there. If I have one of each, a negative 3 and a positive 8, that gives me my 5 that I want. And so my two terms are negative 3 and 8. Remember, we write them both over the leading coefficient. In this case, my leading coefficient is 2. So I write them both over 2m and 2m. Again, the 2m, we'll put the m with it more just for a placeholder. So does this simplify? 2m minus 3? Absolutely not. This is 2m minus 3. Okay, so there is no number that goes into both 3 and m besides 1. In the second one, 2 and 8 have a common factor. It's 2. 2 goes into 2 once. It goes in there 4 times. And so I'm left with m and positive 4, so that's m plus 4. And again, if you want to check that, you can go ahead and FOIL. What about letter D? Well, in letter D, we can simply factor a 5 out. Every term is a multiple of 5. So if I factor a 5 out, I end up with z squared minus 5z and plus 8. Now, we can use snip method or we can use what we used yesterday because the leading coefficient in this case inside of here is a 1. So we need two numbers that multiply to make 8 that add to make 5. Well, let's start thinking about factors of 8. 1 and 8, 2 and 4, that's it. And none of those factors add to 5. So that means that this cannot be factored. Now, just so you guys understand, when we stop factoring, when we get to a prime polynomial. So a prime polynomial is one that cannot be factored anymore. Okay, stop factoring that because this z squared minus 5z plus 8 happens to be what we call a prime polynomial. 2 checkpoint problems, guys. Give them a shot. Pause your video and then resume and check your solutions. In number 5, since both of these are divisible by 4, we can bring a 4 out of both of these. And if I factor a 4 out of 36x squared, that leaves 9x squared. And if I factor a 4 out of 16, that leaves minus 4. And so I'm going to put my 4 out in front, and it becomes 9x squared minus 4. Now you might think, well, I'm done. But you're not, because take a look at this. Isn't this a perfect square? Yeah, what did I square to get 9x squared? I squared 3x, right? And what did I square to get 4? Well, I squared 2. So this is the difference of two things that are perfect squares. This becomes 4 times 3x plus 2, 3x minus 2. And that one's a little bit lengthy. How about the second example here? Well, in the second example, we have to first factor out, since all of these numbers are divisible by 3, I'm first going to factor out a 3. When I bring a 3 out, that leaves me 5p squared plus 8p and then minus 21. So now I need two numbers that multiply to make whatever a times c is, that adds to make whatever b is. In this case, a times c, again, forget about the 3. The 3 is outside of the parentheses. It is 5 times negative 21. 5 times negative 21 becomes negative 105. All right, and in b is 8. So I need two numbers that multiply to make negative 105 to add to 8. Now first of all, because this is negative 105, I know I need one of each. So I'm just going to put this down below here. 3 times there and there. I need a plus and I need a minus. The only way I'm going to get negative 63 is if I have one of each, right? Okay, so having said that then, we want to take a look at the possibilities that are factors of 105. Now, this is kind of hard because 105 is not a very small number. So 1 in 105, 3 in 35, and just with a little bit of work on your calculator, you can pretty easily get these factors. And so those are the possible numbers that evenly divide into 105. Those are the pairs that I can use to multiply to make 105. Which pair of them, when I have one of each, will add to positive 8? Well, I need positive 8, so that means I need the bigger number to be positive and the smaller to be negative. And so as I look through my possibilities, it becomes very obvious that that is negative 7 plus 15, which is 8. And so like we said before, we put them both over 5p. And make sure you do the 5p because that's the leading coefficient. That's what a is. A in this case is the 5. The 3 is just kind of out here for now. We're going to leave it outside of there and deal with that later. So 5p take away 7 doesn't simplify. This is 5p take away 7. The other term, though, because this is 5p and 15, 5 goes into 15 3 times. I end up with p and positive 3, so this is p and 3. Now, like I said, you can go ahead and FOIL this first and then distribute the 3, or you could distribute the 3 here and then FOIL. You're going to get the same idea. Okay? All right, last but not least, solving a quadratic equation. Well, if you're solving a quadratic equation, effectively what we want to do still is we still want to get to this idea here. The zero product property says if the product of two things is equal to 0, then either A is 0 or B is 0. So if I could write this polynomial as the product of two factors, then I could very easily solve that. So how do I solve, or how do I factor two numbers that multiply to make negative 42 that add to make negative 1? While you're looking at negative 42, guys, don't forget it's negative 21 times 2, which is negative 42. I need to multiply to negative 42 and add to make negative 1. So again, because it's negative here and because it's negative here, I know that I need one of each. So factors of 42 are like 1 in 42 and blah, blah, blah. But I know a set of factors that are 1 away from each other, which is 6 and 7. So the only way I'm going to get negative 1 when I add them is if I go negative 7 and positive 6. So these two will multiply to make my negative 42, and they will add to make my negative 1. So write them both over the leading coefficient with an x. And so my two possibilities then are 2x minus 7. All right, so let's put the 2x minus 7 here, 2x minus 7. And then the other term, since 2 goes into 6 3 times, this is 3 and then plus x. I'm sorry, x and then plus 3. All right, because of the zero product property, we can say then that 2x minus 7 is equal to 0, or x plus 3 is equal to 0. Well, that one's pretty easy. X equals negative 3. The other one, you have to add 7 to both sides. You get 2x equals 7. When you divide by 2, you get x equals 7 over 2, or 3.5, whichever way you want to write it. Okay? For letter B here, you'll notice that we've got some stuff on the other side, right? To solve something using the zero product property, guys, it's got to be equal to 0. So our first order of business is to put it in standard form. I'm going to subtract 6r and add 12 to this side, to the right side. And so over here, I'm going to minus 6r, and I'm going to add 12. And so now you have 4r squared minus 24r plus 36. Now, before we start working snip method here, guys, take a look. Recognize that all of these numbers are divisible by 4. So I'm going to factor out a 4. That leaves me r squared minus 6r plus 9. Okay? Now, if you notice here, this is 4 times this mess is equal to 0. And by the zero product property, either 4 equals 0 or r squared minus 6r plus 9 equals 0. Well, can 4 be equal to 0? Well, no, it can't. So that basically means that if I divide both sides of this thing by 4, that effectively says, look, that's just garbage, let's just get rid of that. And so now we have this piece left, the r squared minus 6r plus 9 is equal to 0. R squared minus 6r plus 9 is equal to 0. So let's factor it. Now, before I start factoring again, you need two numbers that multiply to 9 that add to negative 6. Some of you guys already recognize that r squared is a perfect square, and so is 9. So what did I square to get r squared? Well, I squared r. And what did I square to get 9? I squared 3. So those are both perfect squares. And then in between those, you have minus 6r, which if I do 3 times r, that's negative 3r. And then double it, you get negative 6r. This happens to be a perfect square trinomial, so this is r minus 3 quantity squared. So either r minus 3 equals 0 or r minus 3 equals 0, right? Because this is the product of r minus 3 times r minus 3. Well, look, you're solving the same equation twice, right? Add 3 to both sides and you get r equals 3. Last two checkpoint problems, guys. Go ahead and give these a shot. Let's see how you do, and then we'll be right back with solutions for those. All right, in number 7, they're all even. So this is 2x squared plus 2x minus 15 is equal to 0. And so what we have to do then is we have to say, look, the 2 is basically going to be irrelevant, because if I divide both sides by 2, 0 divided by 2 is still 0. So I get x squared plus 2x minus 15 is equal to 0. No snip method required here because the leading coefficient's 1. You can use it if you want. You don't have to. Two numbers that multiply to make negative 15 that add to make positive 2. That tells me to get negative 15, I need one of each. So it's x and x. And then it's got to be positive 5 and negative 3 because those two numbers multiply to negative 15 and add to positive 2. So then I have x plus 5 equals 0 or x minus 3 equals 0. And when I solve these, I minus 5, and I get x equals negative 5 or x equals positive 3. Because again, when I add 3 here and add 3 here, I get x equals 3. What about number 8? Well, number 8 has to be in standard form first. So first I'm going to subtract 5z and add 4 to the right side, and I got to do that to the left side too. It's a little bit confusing because of the way the margins worked in here. But basically, if I subtract that and add that, on the right side I've got 0. On the left side I have z squared, and then 13z minus 5z becomes plus 8z, and then positive 12 and 4 becomes positive 16. Okay? Now, conveniently, this is a perfect square, and this is a perfect square. And if I do, what did I square to get z squared? Squared z. What did I square to get 16? I squared 4. What's z times 4? That's 4z, and if I double it, I get 8z. This is a perfect square trinomial. So this is z plus 4 squared equals 0. So z equals negative 4, because when I rewrite this is z plus 4 equals 0, or z plus 4 equals 0, right? It's the product of z plus 4 times itself. And so you're going to get your one solution is negative 4. Now, do not lose sight of the fact that if I were to plug negative 4 back into this original equation, it would be true. If I plug negative 5 into this original equation, it would be true. The same thing with 3. It would be true. Make sure you plug in negative 5 in both cases. Plug in the 3 in both cases.